Hey guys, welcome back to my YouTube channel. So in this lecture, we are to start the next discussion on what will be the Fermi level energy gap between the EFN and intrinsic level. So in this last lecture, we have three different formulas. Like this is for the intrinsic, and this gives the mid energy level, the EFI. What will be the location of EFI? And here you see there will be the distance between the conduction band lower energy level to that of Fermi level, the donor acceptor energy level, which is formed in N type, and the P type will give the difference between the EFP, that is Fermi level formed by the acceptor atom, to that of valence band. But if you see another one, two distance is pending, that what will be the distance between the donor energy level, let me show in the graph. So this one we are done, and then this one EFP, right? So this distance we are done, and this mid level we are done. But this one, this is the fourth one, and this is fifth one. So these two things we have to done. So we have find out three formulas. So now this is the fourth one. So clearly you can see there is a link between N type and intrinsic. So we need to connect both the things, like what will be the N and those values. So we know that N, which is equal to NC e power minus EC minus EFN divided by KT. Okay, so it will be proxy equal to ND. So these things we know. So an intrinsic N, which is also equal to Ni, right? So which is equal to NC e power minus EC minus EFI divided by KT. Okay, so now what we can do is that we can relate these two terms. So if we done it, then this can be written as NN, because that is a N value in an N type. So that thing we can represent like this. So let's divide both the term. So if we divide both the term, NN divided by Ni, so this term will come, this NC will be cancelling, and this term will go up. So I'm directly writing it. So e power minus EC, this term will remain as it is. So EFN divided by KT, right? Into product that we are from the denominator we are going to numerator. So this negative will change to positive. So e power EC minus EFI divided by KT. Okay, so let's group all the thing because our this is in product term, right? So minus EC minus EFN, this will become minus because we are taking minus outside. So EC, this will become plus EFI divided by KT, right? Divided by KT, that is there. So if we cancel this term, so this and this will be cancelled, and this will be equal to e power. So let's bring the negative sign inside. So that will be EFN minus EFI divided by KT. Okay, so let's rewrite this formula. So this will be equal to NN divided by Ni, which will be equal to e power EFN minus EFI divided by KT. Okay, so this is the value. So let's rewrite it again. So if we take a ln another thing, the EFI minus EA, this is the required thing, right? So it will be equal to KT ln NN divided by Ni. We have done nothing. So we have took ln on both sides and make this term, and this is into product. So as we done last, right? So it will be proxy equal to KT ln NN can be written as donor atom. So ND divided by Ni. Okay, so this is the fourth one we are getting. So let's get into the fifth term. So this is similar to that, which is EFI minus EFP. Okay, so this is with the P type and N type. So this one we need to initialize it. Okay, so let's make both the term equal. So P which will be equal to NV e power minus EFP minus EV divided by KT. Okay, so it should be proxy equal to ND, Na acceptor atom. Then P, which is equal to Ni, so which is equal to NV e power minus EFI minus EV divided by KT. Okay, so let's divide both the term. So PP divided by NI. So as we done lastly, right? So same thing. So we are dividing and grouping together. So I'm doing in the same step. So EFP minus EB will be same. This will become top and we are removing negative sign there. So which is equal to EFI plus EV divided by KT. Okay. So this term will be get cancelled and which will be equal to e power. So let's bring the negative sign inside. So EFI minus EFP divided by KT. Okay, so let's rewrite it again. So if we take ln and equate it, so EFI minus EFP, which will be equal to KT ln NA divided by NI. So this is the fifth form we are finding out. So I hope everything is fine. So all the distance are found out here. So next we have to we can directly relate it here. So let me write that one. So let me draw a graph over here. So next place let me draw it. So which is nothing but EC. So let's take the mid. So that is EFI and this is EV. Okay. So this is donor atom. So EFN, the intrinsic Fermi level, sorry, energy n-type Fermi level, and this is p-type Fermi level. Okay. So let's name all the things. So EC, EFI, and EV. So I will be giving you one trick to remember all the things. So this is EFP, this is EFN. Okay. So we know that the density concentration will be called as NC here, and here will be NV. So here we can call as NA, which will be proxy equal to P, and here we call ND, which will be proxy equal to N. Okay. So this is NA because it is intrinsic level. So this distance, which is what, EC minus EFN. Okay. So try to answer it. I will fill it. So which is nothing but EFN minus EFI. Okay. So this distance is EFI minus EFP. Okay. So 4 distances we are getting. So EFP minus EV. Okay. So everything will be same. KT, KT, KT. So we are clubbing. We so far found out all the things, right? So we are clubbing together, but there is some shortcut. So this is also ln. Okay. So this is NC, this is ND. So we can write this directly as N. N or ND. We can even write this as this. KT ln NC divided by ND. Okay, based on question dependency, we can choose any value. Okay, this is what we have find out in first one. You see this one only we are writing there. I hope you guys getting right. So this is first one, first to find out one. So this one we have find out in fourth one, right? Fourth term. So KT ln N divided by NI. So which can be written as KT ln ND divided by NI. So here it is ln P divided by Ni. So it will be proxy equal to KT ln Na divided by Ni. So here will be the quite difference. Here you see the upper term divided by lower term, upper term divided by lower term. But here it's an inverse. Lower term divided by upper term, P divided by Ni. So that thing we have done here. So P can be all out of Ni. So similarly here also an reverse. So NV divided by P. So NV divided by P. Okay. Which will be proxy equal to KT ln NV divided by Na. Okay. So this is one of the very important graphical observation. So you guys have to remember. So far in the last 3 to 4 lecture, we have find out the exact difference. So which is nothing but which is relaying us a distance, difference of distance between everything. So the distance between from this level to this level is this one, from this level to this one. So these are all the study observations, like how the Fermi level, energy levels will be varying. So this exact position we have found it in the first equation, right? So from that we can plot the what will be the EFX location. From that, then based upon the NC, NV and NA and those formulas, we can calculate the difference and how the Fermi level and energy level should be lying. So this one will be fixed, but these three will vary based upon the concentration of N type, P type, temperature and those things. So everything will be dependent on temperature and then the concentration N and P. So this is one of the very important criteria to locate all these distances. Okay, I hope it is very understood for you guys. So in the next lecture we have to go through one more calculation and we'll be going over the problems, some sample problems like how to solve these things. So the thing is that in this lecture we will be equating the mass action law, another one last observation you have to do. But apart from this table will be giving you a very good understanding, I hope. So this is one of the very important thing. Plenty of GATE and IES questions are asked from here. Even in college levels also they will ask. If you guys know these kind of between structure separation of band level, then you guys will able to understand how the electron conduction process is happening. Your analog devices like EDC, that thing will also be very much good for you guys. Electrical circuit analysis will also be very much good. I hope it's understood for you guys. So I'm leaving this to you. So please like, share and subscribe the channel and try to follow up these sections. Please take a note of all the things as it will be very important. It will be very helpful in every situation. Okay, thank you. Stay tuned.